I will show you how to solve square root equations and later on cubic equations as well, cube root equations. So to solve square root equation, there are three steps that must be taken. The first step is to isolate the radical term. And the next step is to take squares of both sides. And then the very important last step is to check for extraneous solution. Here is a simple example to get us started. The square root of 2x plus 9 minus 2 equals 3. Okay, now we're going to apply the first step. The first step is to isolate the radical. We can see from here that the radical is not isolated. Here is the radical term, here's another term, and here is another term. Okay, we need to get rid of this minus 2, this term, so that this term can be by itself. So the first thing we will do is to add 2 to both sides. So we're going to have square root of 2x plus 9 equals 5. Okay, so step 1 is done. Now we're going to go to step 2. We're going to take square of both sides. So it's better to use parentheses when squaring. So we're going to take square of both sides. Here we go. Now, this square and the square root are inverse operations. Square root and square are inverse operations, so they cancel each other out, leaving us with the radicand by itself. So 2x plus 9 will be left, and that is 25. 5 times 5 is 25. And now this is a simple linear equation that we can actually solve. Okay, so that's what I was saying. There's a simple linear equation that can be solved. We can isolate the x by itself. So we're going to subtract 9 from both sides. And we're going to have 2x equals, this will cancel. 25 minus 9 is 16. So we're going to have 16. And then we divide both sides by 2. This 5 divide both sides by 2. And that will leave us with x equals 8. X equals 8. Now we need to check. We need to do the last step. We need to check for extraneous solution. Now in square root, when you're solving square root equation, it is possible for extraneous solution to arise due to the squaring process. So we're going to always have to check for extraneous solution every single time we solve square root equations. So we're going to go back and substitute x into the original equation. So we're going to check. So check. Very, very important. We must always check. So we're going to substitute 2 times 8 plus 9 minus 2 equals 3. We're going to see if that is true or not true. 2 times 6 is 16. 16 plus 9 is 25. So square root of 25 minus 2, is that equal to 3? We are not sure. Okay, let's see. 25. Square root of 25 is 5. And then 5 minus 2 equals 3. Okay, which is true. 3 equals 3. And the left side is equal to the right side. So there is no extraneous solution. The only solution is s equals 8. So we're going to write our solution in set notations. So 8. This is our solution to the equation. All right, that's example 1. Here is another example. Okay, so we have, let's get this out. Now we have 3x minus 1 plus 1, rather, square root of that, plus 1 equals x. Okay, so just making sure you can see everything. Okay, here we go. So we have 3x plus 1, square root of that, plus 1 equals x. So again, we're going to follow the 3 steps. First, we're going to isolate the radical term, take squares of both sides, and check for extraneous solution. So always take those 3 steps. So step 1 is to get rid of this 1 from both sides. So minus 1, minus 1. So this will be left by itself as 3x plus 1. And this other side will be x minus 1. Okay, so now we are going to square both sides according to the steps. So we're going to take square of both sides. 3x plus 1 squared and x minus 1 squared. So now we are going to these inverse operations will cancel out. Square root and square are going to cancel out. So 3x plus 1 equals, now we're going to do binomial expansion. So which is just basically x squared minus 2x plus 1. That's the binomial expansion of that. And now we are going to, this is basically a quadratic equation. This is quadratic. So we're going to solve this quadratic equation that we have. To do that, we need to get everything to one side and get 0 on one side. So we're just going to do minus 3x minus 1. So we are going to have a 0 on the left side. And then we're going to do minus 3x minus 1 and combine like terms. So this is going to cancel. It's going to be 0 equals x squared. Nothing is adding to it. The 2x and the 3x will be negative 5x. And then 1 and 1 will cancel, which will be 0. So now we have a simple quadratic equation like that, which we can actually factor. So x squared minus 5x equals 0. And now we're going to go ahead and factor this. Let's factor this. So x is common. X minus 5 equals 0. So we're going to set each factor to 0. So x equals 0. That's 0 for that. Or x equals 5. That's 0 for that. Now we have two solutions, but we are not done. We must check with the original equation. So we're going to go back all the way to the original equation to check. We're going to check with this. So we're going to check square root 3 and 0 plus 1 equals 0. Notice that I plug in x to every single appearance of x. So x is 0 here, x is 0 here. So I plug in 0 for x, anywhere x is showing up. So 3 times 0 is 0, 0 plus 1 is 1, square root of 1 plus 1, is that equal to 0? I'm not sure. Let's see. Square root of 1 is 1. 1 plus 1 equals 0. The left side is 2 equals 0. That is not true. So 0 is an extraneous solution. All right, let's test the other one. We're going to test the other equation solution. S equals 5. So we have s equals 5 as the other solution. Let's test that. Square root 3 times 5 plus 1 plus 1 plus 1 equals 0. Let's see if that is true or not. So we're going to do 3 times 5 is 15 plus 1 is 16. So square root of 16. Oh, not 0. I'm sorry. That's 5. That's 5. Should be 5 over there. I got distracted by myself. We're going to plug in everywhere we see x. We'll plug in 5. 3 times 5 and then 5 over there. Okay, that's what I was trying to do. All right, 16 and then plus 1. Square root of 16 is 4. 4 plus 1 is equal to 5. 5 equals 5. So that means it's actually true. So 5 is a solution. 0 is not. So we're going to write our final answer in set notation. 5 is the only solution. And that's our answer there, right there. 5 is the only solution. Okay, here is another example. I think we need to do 2 more examples. Where is the example? Okay, I pause. Okay, here is another example. Square root x minus 1 equals x minus 7. To solve this, we are going to isolate the radical Luckily, it's already isolated. It's isolated for us. So yeah, it is isolated. Then the next thing is to take square of both sides. So we're going to take square of both sides. X minus 1 squared and x minus 7 squared. The square root and the square inverse operations will cancel out. So x minus 1 equals, and then we do the binomial expansion of this right side. So that will be s squared minus 14x plus 49. And now we can, this is a quadratic equation that need to be solved by moving everything to one side. So minus x plus 1, minus x plus 1. And so we're going to have 0 equals s squared minus 15x plus 50. Okay, so that is what we have. So now this is a quadratic equation. The next thing we need to do is we're going to see if we can factor this. So we're going to try to break 50 into 2. So here is 50. See if we can break into 2 factors. Obviously, 5 and 10 are what come to mind. And we want to have negative 15, so both of them have to be negative. So we can actually factor it. 0 equals factor x minus 5 and x minus 10. Now, the 0 for each of these factors will be x equals 5, and the 0 for this will be x equals 10. So we have 2 solutions. We need to check now to see if it is true. That's our last step. We're going to check. Square root of 5 minus 1, that's our first one, equals 5 minus 7. So notice that I plug in 5 to every instance of x. There's x there, that's 5. And there's x over here, that's another 5. Okay, so we're going to just try to simplify this. 5 minus 1 is 4, so square root of 4 is 2. So square root of 4, this is 5 minus 7 is negative 2. And 2 equals negative 2. That is false. That's not true. So x equals 5 is an extraneous solution. Okay. Now we're going to test s equals 10. So we're going to do the same thing with s equals 10. So here we go. Square root 10 minus 1 equals 10 minus 7. Okay, so 10 minus 1 is 9. And 10 minus 7 here is 3. Square root of 9 is 3. 3 equals 3. Checks. So 10 is a solution. S equals 10 is a solution. So we're just going to indicate that as the only solution by writing the 10. We go back to our solution here and write 10 is the only solution. Write it in this set notation. And that is our solution to that. Okay, yes, one more example of solving square root equation. I have square root of x minus 6 equals x. So it's already isolated, so we just take square. We're going to take the square of both sides. So excuse me. Now we take square of both sides. So square root x plus 6 squared and x squared. So we're going to have x plus 6 equals x squared, because the square and the square root, they kind of cancel each other out. And now we can get everything to one side. Minus x minus 6 minus x minus 6. Here will be 0. And it will be x squared minus x minus 6. Because it's unlike terms, so we just have to write everything out. So we're going to factor this. So minus 6 will be negative 3 and 2 will give me negative 1x. So x minus 3, x plus 2. So equals 0. So the 0 of this will be s equals 3. And the 0 of this will be s equals negative 2. As usual, we need to go check. So we're going to check square root. Let's check with 3. So 3 plus 6 equals 3. 3 plus 6 is 9. Square root of 9 equals 3. 3 equals 3. that checks. So 3 is a solution. 3 is a solution. Now we're going to check for with x equals -2. Square root -2 plus 6 equals -2. We're not sure, so we're going to see. -2 plus 6 is 4. Square root of 4 equals -2. Square root of 4 is 2. 2 equals -2. That is not true. So this is not a solution. So s equals -2 is an extraneous solution. Okay, now we're going to do one with a cube root. Okay, here is our last example with a cube root. So we have cube root of 2x plus 5 equals 3. Okay, this is a cube root, it's not square root. So we need to, instead of taking square of both sides, we will take cube of both sides. The inverse of cube root is cube, so we look like this. Cube root 2x plus 5 cubed equals 3 cubed. So cube root, cube, opposite inverse operation are going to cancel each other out, leaving you with just the radicand. 2x plus 5 equals 27. And now we can subtract 5 from both sides. So 2x equals, this is -5, 22. And then divide both sides by 2. So x equals 11. We can check to be sure that we are on the right track. So cube root of 2 times 22 plus 5 is that equal to 3. 44 plus 5. So if we do 44 plus 5, that is 49. Oh, this is 11. I'm sorry. This is 11. 2 times 11 is 22. 22 plus 5, that is 27. So cube root of 27 is that equal to 3? Yes, because cube root of 27 is 3. 3 times 3 times 3 is 27. So therefore, 11 is our solution. Okay, so I will do it's a very complex solution example in another video. So hope this video helps a little bit. Thanks for watching.